Alright, hey guys, we're going to be talking about parallel lines and transversals. Now I want you to go ahead and get your workbook out. You're going to be taking notes on page 47 and the pages following that. So make sure you have your workbook open to page 47. Alright, so first things first, remember that parallel lines have the same slope, which means that they will never intersect. And we draw these little arrows like here and here in order to show that they are parallel or have the same slope. Alright, so a couple things that we need to discuss, okay? A transversal is a line that intersects two different lines. So right here and here are two intersection points, and the only line that crosses both of these points is T, which is my transversal here, okay? So what we need to know is that corresponding angles are angles that lie on the same side of the transversal and on the same side of the intersecting lines. So what that means would be example number 1 and 5. Those angles are corresponding. Okay, notice they both lie above the intersected lines and to the left of the transversal. That could mean that 4 and 8 are corresponding. That could mean that 7 and 3 are corresponding, and it could also mean that 6 and 2 are corresponding. So all of those are pairs of corresponding angles. Now, same side interior, so I'm going to erase what I have. Okay, interior means they have to lie in between the two lines. Okay, and it also, same side means it's on the same side of the transversal. So what that means is angles 3 and 6 are on the same side and the interior, and angle 4 and 5 are same side interior angles. Now alternate, remember alternate is not, it's like every other, okay? So when we're alternating, it means non-adjacent angles, meaning the angles can't lie next to each other, okay? And interior means in between the two. So if, for example, angle 3 and angle 5 are alternate interior angles, while angle 4 and angle 6 are another pair of alternate interior angles. Now, alternate exterior angles are similar to interior, except that they'll be on the outside. So, for example, 2 and 8 are alternate exterior, and so are 1 and 7. They alternate on which side of the transversal they're on, and interior means inside of the two lines, while exterior means outside of the two lines. Alright, so the same side interior angles postulate. If two parallel lines are cut by a transversal, then the pairs of the same side interior angles are supplementary. What that means is that angle 3 and angle 6 would have to be supplementary. It also means that angle 4 and angle 5 are supplementary as well. It says, explain how you would find the measure of angle 3 in the postulate diagram if P is parallel to Q and angle 6 is 61 degrees. Since angle 3 and angle 6 are same side interior, we know they're supplementary and must add to 180 degrees. So I'm going to substitute angle 6 in for 61 degrees in for angle 6. By subtracting 61 from both sides, the subtraction property, I get that the angle 3 is 119 degrees. Okay, it says that suppose P is parallel to Q and line T is perpendicular to line P. So let's say this right here is a right angle. How would you also be able to explain that T is perpendicular to line Q? Well, first off, if I know that if line T is perpendicular to line P, then all four of these angles are 90 degrees. If angle 3 is 90, then the measure of angle 6 plus 90 degrees equals 180. That means that angle 6 has to also be 90 because of the same side interior. They have to be supplementary. So if the measure of angle 6 is 90 degrees, that means that line T is parallel to line Q. Oops, get a little messy there. Line Q. Alright, so this time we're going to prove the alternate interior angle theorem. Notice here I have a whole bunch of different properties and equalities and postulates and theorems. We are going to drag and drop these into the correct place. It says, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles have the same measure. So we're saying, given that P is parallel to Q, we've already got the markings here and here, that angle 3 must be equal to angle 5. Alright, so let's get to work. First off, we are given that angle P, or line P is parallel to line Q. We know that angle 3 and angle 6 are supplementary because of the last side. It's called same side interior angles postulate. Which means that angle 6 plus angle 3 has to be 180 because that's just the definition of supplementary angles. Because they're supplementary, they add to 180. We also know that angle 5 and angle 6 are linear pairs. That's actually given in the picture. While it's not necessarily given here, it's given in the diagram. So you can write given in the diagram or just given. We know that angle 5 and angle 6 are supplementary because they are linear pairs, so by the linear pair theorem. And by the definition of supplementary angles, that means they have to add to 180. By the substitution property, I can say that both angle 3 plus angle 6 and angle 5 and angle 6 added together are equal to each other because they both equal 180. Okay, so I'm going to scroll down a little bit. The measure of angle 3 equals the measure of angle 5. All I had to do was subtract the measure of angle 6 from both sides. So that would be subtraction property of equality. So our first question says, suppose that the measure of angle 4 is 57 degrees. How would you also define angle 6? Well, first off, angle 4 and angle 6 are what we call alternate interior angles. So therefore, the measure of angle 6 has to also be 57 degrees. Another way that you could do this is that you could say, okay, if angle 4 is 57 degrees, then angle 3 would be 180 minus 57, because they're supplementary, and then angle 6 would be 180 minus angle 3, which would then give you back 57 degrees. Alright, explain why angle 1, angle 3, angle 5, and angle 7 all have the same measure. Well, first off, angle 1 and angle 3 are vertical angles, so they are equal. Angle 3 and angle 5 are alternate interior angles. And we know that angle 5 is equal to angle 7 by the vertical angle theorem. So by the transitive property, all four angles are equal to each other. Alright, in the figure above, is it possible for all 8 angles to have the same measure? If so, what would be the measure? And the answer to this is yes. If one of the angles is 90 degrees, then they would all chain reaction be 90 degrees. So that measure would have to be 90 degrees. Okay, and that's assuming that the two lines P and Q are parallel. Alright, we're going to prove the corresponding angles theorem. Remember, corresponding angles are on the same side of the transversal and the same side of the parallel line. So in our case, the example would be angle 1 and angle 5. Well, first off, we have that P is parallel to Q. That is a statement in the given. So you're going to write given. We're also said that angle 3 is equal to the measure of angle 5. Okay, well, we know that because of the alternate interior angle theorem. We also know that angle 1 is congruent to angle 3 by the vertical angle theorem. Therefore, we can say that the measure of angle 1 is equal to the measure of angle 5 by either the transitive or the substitution property. You can take your pick. And there we go. We have proven that corresponding angles have to be equal. Notice that once you've started proving things, like the vertical angle theorem and the alternate interior angle theorem, we can use them to shorten the proof of later proofs. Alright, it says prove the equal measure linear pair theorem. Dun dun dun! It sounds very awful, but I promise you it's not as bad as you think. Basically what it's saying is I have two angles, angle 1 and angle 2. They make a linear pair. Let's say that those two angles are equal in measure, then they have to be 90 degrees. Well, first off, you know linear pair angles are supplementary. And if they're supplementary and congruent, don't they have to be right? Because that's the only case where 90 plus 90 equals 180. That's the only case where they're the same and supplementary. Alright, so it is given that angle 1 and angle 2 form a linear pair. Therefore, angle 1 and angle 2 are supplementary by the linear pair theorem. By the definition of supplementary angles, we know that the measure of angle 1 plus the measure of angle 2 is 180 degrees. It is also given that the measure of angle 1 equals the measure of angle 2. We're given that. So the measure of angle 1 plus the measure of angle 1 equals 180 degrees by the substitution property. By simplifying, they get 2m2 times the measure of angle 1 equals 180 degrees. Therefore, the measure of angle 1 equals 90 degrees by the division property. They divided by 2. Therefore, angle 1 is a right angle, and line L and line M are perpendicular to each other by the definition of perpendicular lines. Remember, perpendicular lines meet at a right angle. If we can prove that they have a right angle, then they must be perpendicular. Alright, state the converse of the equal measure linear pair theorem shown above. Is the converse true? So we're going to use our logic here. It says, in the linear pair theorem, if two intersecting lines form a linear pair of angles with equal measures, then the lines are perpendicular. So, if the lines are perpendicular, so let's say, if the lines are perpendicular, then they form a linear pair of angles with equal. So the converse of this is true. Let's say that I have two perpendicular lines. Okay, then they're going to form a linear pair of angles with equal measure, and that is true. Okay? Alright, so let's use what we've proven to solve. Here we've given a problem that this angle is 133 degrees, and this angle is the measure of angle 1. I need to solve for the measure of angle 1. Okay, these are what we call same side interiors, so we know that 133 degrees plus the measure of angle 1 better be equal to 180 degrees. By subtracting 133, we get that the measure of angle 1 is 47 degrees. Okay, here we have corresponding angles, and remember that corresponding angles are congruent. Therefore, the measure of angle 2 has to be 119 degrees. Alright, in this problem we have to do a couple steps. Okay, first and foremost, x is over here and 83 is here. We are not corresponding, same side, alternate interior. We are none of these. However, I can say that by the vertical angle theorem, this angle is also 83 degrees. That means that x plus 83 degrees must be equal to 180 because of the same side interior theorem. So by subtracting 83, I get that x is equal to 97 degrees. So the measure of angle ABC, or x, is 97 degrees. Alright, and last but not least, we have two of these, okay? I want to pause right here and give it a shot. Alright, before you get too far, that 6x is actually an 8x, and I believe that's on page 54 of your workbook, so give it a try. Okay, so these are alternate interior angles, so we can set 8x minus 34 equal to 5x plus 2. Alright, so as you can see, I've done my work here. Each step I've shown what I did in blue and then simplified in red, and then make sure that you take your answer and plug it back in to find the measure of the angle. 5 times 12 plus 2 is 62 degrees. Alright, that's it for today. I will see you later.